Assalamualaikum. Now we still on the topic molecular geometry. Okay, for the second type is molecules with lone pair on central atom. So it seems more complicated because the repulsion occur. Okay, so kat sini ada contoh 3 compound. Okay, ini adalah methane, semuanya adalah bonding pair. The second is ammonia, NH3. So on central atom has one lone pair and bonding pair, and the last molecules for central atom oxygen has two lone pair and the bonding pair. Okay, so the repulsion between three molecules, the higher repulsion is for this one between lone pair and lone pair. Okay, so lone pair between lone pair has higher repulsion compared to lone pair and bonding pair. Okay, pada second molecule. Lone pair and bonding pair, the repulsion are higher than the bonding pairs and bonding pair. Okay, so the first type, previous study, adalah molekul yang tiada lone pair pada central atom. Okay, so contohnya ni adalah tetrahedral. So the angle 109.5 degree. Okay, so bila ada lone pair, okay, ada exist lone pair on central atom. So the repulsion between lone pair and bonding pair here slightly higher. So dia akan menolak angle tu. Okay, the repulse. So the angle much smaller. Okay, and the result is the shape is not as the previous one. Okay, so berlaku perubahan pada geometri. Okay, so yang ketiga molekul H2O. Okay, the lone pair and lone pair repulsion is the highest one. So it will repel the angle. So the angle has the smallest one. So the structure change. Okay. Okay. So the general formula for molecules with lone pair on central atom is A central atom, B surrounding atom with X the integer, and E is the lone pair on central atom, and Y for integers. Okay, so in previous video for the first type yang pertama tadi bila zero lone pair on central atom. Okay, tak ada lone pair pada central. So kalau 2 bonding pairs linear, 3 bonding pairs trigonal planar, sampai 6 bonding pairs octahedral. Okay, yang tu you kena understand the molecular shape, okay, from the bonding pairs. Okay, untuk type yang kedua, okay, terdapat lone pair pada central. Okay, so contohnya di bawah 3 under 3 electron pass. So okay, 2 bonding pairs and 1 lone pair on central atom. So how about the structure? Okay, kalau kita tengok if 3 bonding pairs, kalau 3 atom bonded kepada central, dia akan form trigonal planar. Okay, tapi bila ada 2 atom bonded to central atom or 2 bonding pairs and another one is lone pair. Okay, so what structure form? Okay, kalau 3 atom bonded to central, dia akan form trigonal planar. Okay, tapi kat sini disebabkan oleh repulsion lone pair and bonding pair, so structure akan distorted. Okay, so dia akan jadi bentuk band. Okay, so next type under 4 electron pairs, if 3 bonding pair and 1 lone pair on central atom. Okay, lone pair kita fokus pada central atom saja. Okay, so kalau 4 atom bonded to central, geometri adalah tetrahedral. Okay, tapi sekarang ni 3 atoms bonded to central atom. Okay, so structure is trigonal pyramidal. Okay. Okay. Contoh you imagine kalau 4 atom bonded to central akan tetrahedral, tapi bila satu atom remove, but there's a lone pair, one lone pair on central, so dia akan jadi base dia, tapak dia trigonal and akan form pyramid. That's why the name is trigonal pyramidal. Okay, next, when 2 bonding pairs and 2 lone pair on central atom. Okay, so kalau penuh 4 atom bonded. Okay, so sekarang ni ada macam ni, sekarang ni ada 2 je atom bonded. Okay, and one lone pair and 2 lone pair here. Okay, so here there's a lone pair, 2 lone pair here, so the repulsion is higher and then it repel, okay, repel each other, so dia akan angle jadi lebih kecil, so structure berubah jadi band structure. Okay. Next, under 5 electron pairs, so if 4 bonding pairs and 1 lone pair on central atom. Okay, so kalau kita tengok kalau semuanya atom 5 atom bonded to central or 5 bonding pairs, so structure molecular geometry adalah trigonal bipyramidal. Okay, so bila kita buang satu atom, so satu jadi lone pair. Okay, another 4 atom bonded to central. Okay, macam ni. Ataupun bila kedudukan okay, 1 lone pair and 4 bonding pairs. Okay, so molecular geometry is seesaw. Okay, macam juga okay, ataupun we call as distorted tetrahedron. Okay, I don't want. Okay, so nampak macam seesaw. Okay. Okay, so you imagine from the general one. Okay, asal trigonal bipyramidal, buang satu atom jadi 1 lone pair, so dia jadi seesaw or distorted tetrahedron. Okay, so sebab tu penting you kena tahu yang the first part, the general. Okay, second types under this, if 3 bonding pairs and 2 lone pair. Okay, so how about the structure? The structure will distorted, okay, become, okay, kalau asal full atom, 5 atom trigonal bipyramidal, sekarang kita buang 2 atom jadi 2 lone pair. Pada central jadi 2 lone pair and 3 atoms bonded to central. Okay, so 1, 2, 3 atom, so lone pair pada atas ni. Okay, so molecular geometry is T-shape. Okay, Kalau you change the position, okay, 3 atom bonded to central and 2 lone pair. Okay, so macam T shape, like T shape, bentuk T. Okay, next, if 2 bonding pairs and 3 lone pair on central atom. Okay, so you ambil pada sini 1, 2, 3 jadi lone pair. Okay, 1, 2 for bonding pairs and 1, 2, 3 for lone pair on central. Okay, so the geometry now change to linear. Okay, and the 5 electron pairs, there are 1 lone pair on central atom, 2 lone pair on central atom, and 3 lone pair on central. Okay. Okay, next, for total electron pair 6, the bonding pair 6, lone pair is 0. That one for general is octahedral. Okay. Type yang seterusnya. Okay, so 6 electron pairs under 6 total. So if 5 bonding pairs and 1 lone pair on central atom. Okay, so 1 lone pair on central, and there are 5 bonding pairs or 5 atom bonded to central atom. Okay, so 1, 2, 3, 4, 5. Okay, so there's 1 lone pair here. So the structure is square pyramidal. Okay, sebab kita imagine daripada kalau total 6 atom bonded pada central octahedral semua, tapi sekarang satu jadi lone pair on central, another is 5 bonding pairs. Okay, so pada base dia bentuk square. Okay, and then akan form satu pyramid pada top. Okay, so that's why the name is square pyramidal. Okay, so the structure is distorted because of the presence of lone pair and bonding pair. Okay. Okay, next, under 6 electron pairs. So there are 4 bonding pairs or 4 atom bonded to central and exists 2 lone pair on central. Okay, kalau kita tengok total 6 electron pairs. Kalau penuh 6 bonding pair like atom, so octahedral. Okay, bila satu jadi lone pair pada central, 5 bonding pair square pyramidal. So bila ada 4 bonding pairs or 4 atom and 2 lone pair on central, so the structure, okay, actually you imagine from octahedral. So sekarang ni ada 4 atom sahaja yang bonded kepada central atom, okay, ataupun 4 bonding pairs only. And then the lone pair location top and bottom here. Okay, so the molecular geometry for this one is square planar. Okay. Okay, so perubahan structure because of the lone pair and bonding pair, the repulsion between that. Okay, so yang ini base nya adalah square in one plane. Okay, that's why the name is square planar. Okay, so okay, that one under if there's a lone pair on central atom. Okay, so this is summary. Okay, actually you understand enough the general one, and for this step you have to imagine like I explained just now. Okay, so untuk Predict molecular geometry, step yang sama, draw Lewis structure, count number electron pairs, bonding pair and lone pair on central atom, focus pada central atom only, and then using Vesper theory to predict the geometry. Okay, so first example is sulfur dioxide. Okay, for sulfur dioxide, for the Lewis structure, 6 valence electron for sulfur, oxygen 6 times 2, 12, and total is 18. Okay, first step, draw Lewis structure. So sulfur as central atom, okay, and oxygen as bonded atom, and then form bonding. Okay, so to know non-bonding electron, 18 minus 4, 2 and another 2 here for bonding pairs. So left 14 non-bonding electron. So kita letakkan lone pair pada oksigen. Okay, so sekarang ada 2, 4, 6, 8, 10, 12. Kena di balance 2, satu lone pair pada sulfur. Okay, so kita tengok check the octet. Untuk oksigen 2, 4, 6, 8. Ke sini untuk sulfur 2, 4, 6. Kita cukup untuk sulfur. Untuk oksigen ini cukup 2, 4, 6, 8. Okay, so to achieve octet for sulfur, okay, form double bond. Okay, so kita form double bond here. Okay, and then sulfur actually on period 3. Okay, if the element on period 3 and above, it can be as expanded octet. Okay, you can look the video for topic after this. Okay, so the possible Lewis structure untuk sulfur dioxide. Kita tengok formal charge dulu untuk oksigen yang ni. Okay, 6 valence electron minus 7, so minus 1. Okay, for sulfur 6 minus 2, 3, 4, 5. Okay, plus 1. Okay, for this oxygen 6 minus 1, 2, 3, 4, 5, 6. Okay, so you want to find the best Lewis structure. Okay, so since sulfur can be expanded octet more than 8 for octet, so we can form another double bond here. Okay, example. Okay, and then we check the formal charge. Okay, so the first 6 minus 1, 2, 3, 4, 5, 6. Okay, valence electron minus electron owned by its atom. Sulfur 6 valence electron minus 1, 2, 3, 4, 5, 6, 0. Okay, this one 6 minus 1, 2, 3, 4, 5, 6. Okay, so this is the best possible structure. Okay, okay, and then identify the bonding pairs around the central atom and how many lone pair on central atom. So for bonding pairs, or how many bonded atom to central atom, there are 2 bonding pairs. Okay, double bond, walaupun double bond kita kira sebagai satu bonding pair. Okay, 1, 2, ataupun you tengok how many atom bonded to central atom. So there are 2 bonding pairs and 1 lone pair on central atom. Okay, so 2 bonding pairs, 1 and 2, and then 1 lone pair on central atom. Focus on central atom. So if under this one, the shape or geometry is bend. Okay, so in geometry form, okay, being like this. Okay, band structure. Okay, next, for ammonia, NH3. Okay, kita try sama-sama. And 5 valence electron. Okay, hydrogen 1 times 3. So total 8 valence electron. And then form Lewis structure. Okay. So 1, 2, 3. Okay, jadi for nitrogen 5 valence electron. So 3 has been shared, 1, 2, 3, and left 1 lone pair. Okay. Ataupun okay, 8 minus 6. So there are 2 non-bonding electron. Okay, ataupun 1 lone pair. Okay, so next determine how many bonding pairs and how many lone pair on central. Okay, so there are 3 lone bonding pair or 3 atom bonded to nitrogen and 1 lone pair on central atom. So the geometry is trigonal pyramidal. Okay. How you want to know if you don't remember? So remember total electron pair around NH3 is 4. Okay, ataupun 4 electron pairs. Include bonding pair and lone pair. Okay, kalau tak ingat. So kalau 4 adalah sebenarnya tetrahedral kan. Tapi yang ini semuanya adalah atom. Okay, sekarang ni yang atom ada 3 saja. Satu adalah lone pair. Okay, so structure adalah tapak trigonal and pyramid. Okay, so kalau dalam bentuk geometri, you have to draw like this. Okay, with lone pair on central atom. Right. Next, H2O, water. Okay. 2 plus 6. So, 8 valence electron. Okay. So 6 valence electron. So 1 and 2 sharing and left 3, 4, 5, 6. Okay, ataupun 8 minus 4 is 4 non-bonding or 2 lone pair pada center pada oksigen. Okay. And then determine how many bonding pairs and how many lone pair. So there are 2 bonding pair ataupun 2 atom bonded pada central and 2 lone pair. Okay. So the structure is sama juga macam tadi tekniknya. Kalau you tak ingat, based on general, if total 4 adalah tetrahedral. Tapi sekarang ni 2 saja yang atom. Okay, so structure is band. Okay, so kalau dalam bentuk geometri, you have to draw like this. Okay, so 2 lone pair on hydrogen. Okay, next, sulfur tetrafluoride, sulfur 6, fluorine 7 times 4. Okay, so total is 34. Okay, so now draw Lewis structure. Okay, so the atom fluorine. 7. So 1, 2, 3, 4, 5, 6, 7. So kita letak lone pair pada atom fluorine. Okay. Sulfur 6. So 1, 2, 3, 4 and left 1 lone pair. Okay. Sini 34 minus bonding pair. So ada 4 bonding pair, ada 2 elektron, 8. Kat sini ada 26. Okay. So 6 bonding, non-bonding elektron pada fluorine darab dengan 4. 6 darab 4, 24 plus 2. Okay, 24 tambah 2 dapat 26 non-bonding elektron. Okay. Ataupun lone pair. So pada sulfur ada 1 lone pair and bonding pairnya 4. Okay, 1, 2, 3, 4. Okay. So 4 bonding pairs, 1 lone pair. Okay. So kalau kita ingat okay, apa geometrinya untuk yang ini. So ingat total 5. Okay, if total 5 actually untuk general yang tak ada lone pair trigonal bipyramidal kan. Tapi yang ini jadikan 1 lone pair. Okay, so dia adalah okay, so bentuknya apa? Kat sini. Okay, adalah seesaw ataupun distorted tetrahedron. Okay. So kalau nak lukis dalam bentuk molecular geometry. Okay, 1 lone pair on sulfur and 4 atom fluorine. Okay, ini bentuk seesaw ataupun distorted tetrahedron. Okay. So next, geometry of molecules with more than 1 central atom. Okay, so we look one by one. Okay, so kalau sebelum ni kita tengok contohnya satu molekul. Okay, yang ni dia ada 1 central atom. Okay, kalau dalam molekul tu ada beberapa central atom, kita kena tengok one by one. So we look at the first here. Actually, this is CH3, C double bond O, OH. So we look at the first central atom, carbon. Okay, so bonded to hydrogen, 3 atom hydrogen, 1, 2, 3, and 1 atom carbon. So dia adalah tetrahedral because there are 4 bonding pair. Okay, so kalau dalam bentuk geometri macam tu. Sini contohnya. Okay, next look at the next central atom, C here, carbon. So bonded to oxygen and carbon. So bonding pairsnya ada 1, 2, 3. Okay. Ataupun tengok kat sini, walaupun double bond kita kira sebagai 1. Okay, 1, 2, 3. So 3 bonding pair. Okay. 0 lone pair on central atom. So the geometry is trigonal planar. Okay. Ingat lagi. Before this. Okay. So trigonal planar. Okay. Next central atom, oxygen. Central atom yang ketiga. Okay, so oxygen, there are 2 bonding pairs here, 1 and 2 ataupun 2 atom bonded pada central, and there are 2 lone pair. Okay, so the structure is band. Okay, so dalam molekul ni ada 3 central atom dan mempunyai molecular geometry yang berbeza lah. Tengok pada how many bonding pairs on central atom and how many lone pair on central atom. Okay. Okay, for the exercise, you can try to do by yourself.